Okay, thank you very much. Exercise 17D is on graphs of differentiation. So it's very similar to what we've actually already done in terms of the instantaneous velocity graph, right? So at graphs of differentiation, if I have a function like this, where my function is a cubic function, can anyone tell me what kind of function is my derivative going to be? Power of 2, perfect. It's going to be a parabola, right? So if I make the blue one my differentiation, I know that at this point there, my differentiation, my gradient is 0. And also at this point over here. Between these 2 points from there to there, I know that it's going down. So it means my gradient is going to be negative. So my derivative is going to be negative. And then from here onwards, it's going to be increasingly positive. And here, it's going to be increasingly positive as well. So this is my to the power of 2, my differential, okay? My differential. So we're actually talking about graphs of differentiation, and we're actually going to be introducing 2 new terms, which are strictly increasing and strictly decreasing. They're generally exactly how they sound. If I have a differential function, so let's go back down. If I have a differential function that looks a bit like this, okay? I know that for any point I choose, whatever point it is, let's say I pick this point over there, the tangent is going to be positive. The gradient of the tangent, sorry. If I pick this point here, it's going to continue to being positive. So no matter what point I pick, my tangent's always going to be positive. Okay? That means it's strictly increasing. Because for all values of x, my f of x, my apologies, sorry, my f dash x is going to be positive or greater than 0. Okay? So no matter what point I pick, throughout all values of x, my gradient is going to be positive. Now, obviously, it's the other way for strictly decreasing. So if I was to go ahead and draw a function that looks like this, now let's assume that's a straight line. If I draw a function like that, it's strictly decreasing. Decreasing. Apologies for my terrible handwriting. It's strictly decreasing because for all values of x, it's got a derivative, or the gradient of that function is going to be negative. Does that make sense? Yeah? Yeah? So for all f dash of x, it's going to be, f dash x is going to be less than 0. In some stages, you will get f dash x equals 0. So if I go back to this cubic function here, at that point right there, it's going to be exactly 0. But we still consider the graph strictly increasing because it doesn't go into the negative, okay? The other thing I want to talk about is signs of a derivative, which generally you guys are actually pretty good at. So if I have a function that looks like this, let's say it looks like that, I know that between certain values, the gradient of my function is going to be positive or negative. So that's really what this exercise is about. We're focusing on that section there. So if, let's say that's 2, that's 4, and that's 0 evidently. I know that my graph for when it's f dash x is greater than 0. So what does f dash x greater than 0 mean in terms of words? In terms of the graph, what does that mean? What is f dash x? Yeah, the derivative. What does the derivative tell me? It tells me the gradient of the function at any point. Okay? So I'm trying to find on this graph, for what values of x will the gradient be positive? Will that be between negative infinity, up until where it goes to here? Sorry, my apologies, not negative infinity. That's positive. Oh, no, that's right, yes, negative infinity, up until it goes up to 0. So that would be 2. But between here and here, it's going down, which means my graph is going to be negative, right? My gradient is going to be negative, so we're going to ignore that for a bit. And I'm going to write from here, 4 up until positive infinity. Now, I don't include 2 and 4, because at those points, my gradient is going to be exactly 0. Do you have a question? Go for it. Okay. Now, if I'm trying to find when my gradient is less than 0, so that is to say when it's negative, it would only be between where x is 2 and x is 4, because that's the only point where my gradient, my tangents or my gradients at that, for those values of x, would give me a negative value. Are we generally okay with that? Yeah? Okay. This is where it gets a little bit more difficult, is when we're talking about the angles associated with the gradient. So let's continue using this example. This formula right here is one we're going to be using quite often. M equals to tangent theta. Now, theta is any angle. I'm not sure if you guys have seen theta before. It just means any angle. So it's the same as any value of x, right? So m, being our gradient that we're quite familiar with, is equal to the tangent theta. Now, theta, if I was to draw another Cartesian plane, if I was to draw a function like this, let's say I select a specific point, let's say over here, my tangent's going to look a bit like that. Okay? That's my tangent at that specific point. What this angle over here, that theta over there, tells me is the angle it makes with the positive direction of the x-axis. By saying that, I'm saying this is the positive direction of the x-axis, so it'd be the angle it makes over here. So this one will be theta. Okay? And that applies for all points. So if I was, for example, select a point over here, let's say I select that point over there, my tangent looks like this. I'd be thinking, well, what's the gradient? So my apologies. What's the angle it makes with the positive direction? Okay? Do you have any questions so far? No? Okay, let's go ahead and do an example. This is typically a question that you would be able to use your calculator for, unless it's for example, tan of 45 degrees. Have you guys done perfect special triangles?
Yes.
Have you guys done special triangles as a class?
Very briefly.
Very briefly, okay. Well, it's not expected you guys are going to be able to, for example, tan of 34 degrees. I'm not expecting you to be able to do that. If you do get a question like that in a calculator free, just leave it as tan 34. But just heads up, your test next week is calculator allowed. Okay. All right, so let's go ahead and do an example. So let's say I've got the function of, let's move down. Say I've got the function of y equals to x squared minus 7x plus 8. And I'm trying to look for the point that makes an angle of 45 degrees. Okay? So I'm trying to find where it makes 45-degree angle. Okay? So remember the formula is m equals to tangent theta. Okay? Now, I know my theta is. I know it's 45 degrees. It's told me in the question. So I'll replace it. I know that m equals to tangent of 45 degrees. Now, just a heads up when you're using the calculator, some of you guys have your calculator set in radian. Please make sure you set it in degrees. Otherwise, you'll have to type in degrees every time. And sometimes they'll give you an answer, it's in radians. So I recommend you just keep it as degrees. Okay? Sometimes you get something a little bit off. All right, so tangent equals to 45 degrees. Now, I know my special triangles. I'm not sure if you guys remember. But tangent 45 degrees is actually just 1. Okay? Now, I'm going to quickly draw it up here. I don't know if you guys remember this stuff. So that's 1, 1, and using Pythagoras. All good, James? All good? Yep, okay. Using Pythagoras, the long side or the hypotenuse is just going to be root of 1 plus 1, 2. Okay? Now, because both sides are the same, I know that's 45 degrees. I know that's also 45 degrees. Okay? Now, this is going to be quite confusing for some of you. For some of you, it'll be a little bit nostalgic, maybe just me. Tangent is opposite over adjacent. You guys remember that? SoCal Toa? Yeah, it's opposite. So let's pick this angle, for example. Opposite would be 1. So Toa, oops. So the opposite would be 1 over adjacent was 1. So that gives me tan of 45 degrees equals to 1. Okay? So I know that m equals to 1. I'm trying to find the value of x for which my gradient is 1. Are we clear on how I got there? Yep? Okay, awesome. Now, how do I find the gradient? How do I find the gradient of a function? Sorry? I could do rise over run, but I've got this function over here. I'm trying to find a specific gradient. What I can do is I can find the derivative. Shut up, bird. Okay, I can find the derivative and then let it equal to 1 because I know that my derivative is 1 or my gradient is 1. I can just find whatever value of x would get me there, right? So let's find dy dx. Now, using my differentiation rules, remember I bring the 2 to the front, so 2x. Life is hard. Okay, I bring the power of 2, I bring it down 1, so it's going to be 1 minus 7, and I don't bring the x, so it's going to be 2x minus 7. Do you remember how to do this part? Yeah?
This is a gradient.
Yep, this is correct. That's the gradient.
And
so I know the gradient.
So it's equal to 1.
That's correct. So I let 2x minus 7 equals to 1. I go ahead and solve it. So I know that 2x equals to 8. I plus 7 on both sides. Divide both sides by 2. I get x equals to 4. But I'm not done yet. The question specified. Now you guys can't see the question because I didn't write it out fully. The question specified to find the coordinate. Okay? To find the coordinate. So if I've got the value of x. I know that x, y equals to 4 and then, oops, and 4 and then some value of y. I don't know what that is yet. If I was to put that back into my differential equation, that's just going to give me the gradient at that point. I don't want to look for the gradient. I want to look for the actual coordinates. Yeah? So I'm going to substitute 4 back into the original equation. So I'm going to write 4, sorry, not y. Y equals to 4 squared minus 7 times 4 plus 8. And that gives me 16 minus 28 plus 8 gives me negative 4. Yeah,
so
negative 4.
So the coordinate is 4, negative 4.
That is correct. 4, negative 4. Do you have any questions about that so far? Does that seem like a relatively okay path in terms of working out? Okay. The only other thing is that sometimes I'll ask you, well, what if it's parallel to this line or perpendicular to this line? Now, do you guys remember what parallel and perpendicular means in terms of straight lines? That's from term 1, yeah? So, for example, let's pick the same function. So I've got y equals to x squared minus 7x plus 8. Okay? Now, if the question says it's parallel, I'm just going to do this for parallel. Parallel to y equals to 3x plus 2, let's say. Now, if it's parallel to that, do I care about any other values except for the gradient? No, I only care about the gradient. What's the gradient of my this equation right there?
3.
3, easy. I know m equals to 3.
mx plus c.
That's correct, mx plus c. So my m equals 3, okay? So I go ahead and do the same thing. I find the derivative, which was 2x, dy dx equals 2x minus 7. That's correct. My gradient is 3, so I let it equal to 3. So 2x minus 7 equals to 3. I add 7 on both sides, so 2x equals to 10. X equals to 5, you get the idea. And then I substitute x equals to 5 back into the original equation. So get y equals to 5 squared minus 7 times 5. I'm going very quickly. How do you guys feel?
25 minus 35 plus 8.
25 minus 35 plus 8, which is y equals to negative 2, I believe.
5
Yep.
negative 2 is our coordinate.
Correct. My coordinate is 5, negative 2. How do we feel about that? Are we okay with that?
Okay.
Generally? Okay. That's it for this exercise. Let me know if you have any questions.